Hello, this is Mr. Wynn, and this video is operations with radical expressions. So remember, a radical expression is just an expression with a root sign or radical sign. Example, square root or cube root. And to simplify a radical expression, make sure all these conditions are met. The first one is the index n is as small as possible. So remember that a radical is just a fraction exponent, and if you can reduce a fraction, you should always do that. Second, the radicand has no factors that can come out. This means that there can be no more groups if you do the tree branch factoring method. The radicand is the number inside the root sign, so this 80 would be the radicand in this problem. Third, the radicand has no fractions, so there cannot be a fraction inside the root symbol, like you can't do square root of a fraction. Now if you see that, you can split it into the root of the top thing divided by the root of the bottom thing. And last, there cannot be a radical in the denominator. If you see that, you need to rationalize the denominator by multiplying by the conjugate. Some important facts to know when simplifying radicals. If you take an odd index root of a negative number, just take out a negative 1. And when taking out an even index root of a negative number, take out an I. So when you see square root of, say, negative 5, you take out I. But if you do the cube root of negative 5, you take out negative 1, and then it'll be cube root 5 inside. Also, don't forget about the even, odd rule when simplifying variables. So, how to add and subtract radicals. The steps are pretty much simplify each radical separately, then combine like terms when possible. And like terms must have the same index and radicand. So, example of like terms, 6 root 7 plus 4 root 7. They both have root 7 at the end. And they're both square roots of 7s. So, 6 plus 4 is 10 root 7. That's like saying 6x plus 4x combines into 10x. The non-example is 6 times the cube root of 7 plus 4 times the fourth root of 7. Cube root 7, fourth root 7 are two different numbers, so they do not combine at all. So let's try this problem. It says square root of 98 plus 4 square root 12 minus 2 square root 32 minus square root 75. They're all different right now. Square root of 98 is not the same thing as square root 12. But I'm trying to simplify each separately. If I break down 98, that is 49 times 2. 49 is 7 and 7. There's a pair of 7s. So what comes out is a 7, and what's inside is root 2. Then over here, I'm going to break down this 12. That's 4 times 3. 4 is 2 times 2. So here's a pair of 2s. So 2 goes out. That 3 stays inside. But do not forget that 4 in front. And there's a positive, and put a plus there. This next one, square root 32. That's 16 times 2. 16 is 4 times 4. I could break this down further. 2, 2. 2, 2. Here's a pair. Here's another pair. So 2 2's comes out. That last 2 stays inside, and don't forget the 2 in front. That's a minus sign. And last 75 is 25 times 3. 25 is 5 times 5. Here's a pair. 5 comes out, that 3 stays in, and there's a minus in front. So if I fix each of these, this first one stays 7 root 2 plus 8 square root 3. Negative 2 times 2 times 2 is negative 8 square root 2. And then that's just minus 5 root 3. 7 root 2. I'm going to come back terms. Let's see black. So here's 7 root 2. Here's negative 8 root 2. Those are both root 2. So 7 minus 8 is negative 1. Negative 1 root 2. Then here's the root 3's. Positive 8 root 3 minus 5 root 3. It's like saying 8x minus 5x. 8 minus 5 is positive 3. And it stays square root 3. That is the answer. Those two do not combine. If I type the original problem in the calculator, got a decimal, and I type my final answer in the calculator, I get the exact same decimal. That's the way you can check. Alright, multiplying radicals. To multiply, outside things go together, inside things go together, if they're the same type of root, so same index. Alright, then you can simplify normal. So here is 4 square root 6 times 2 square root 3 times 5th root of 7. You can put parentheses if you want, but the outside numbers, I'll do like this. Alright, the outside is 2 and 4, so that makes 8. I'll put this right here, 2 times 4. Then the square roots, we have a 6, square root 6, and a square root 3. So those squares combine together. Then we have a 5th root. That 5th root 7 does not combine with anything. I can multiply. 2 times 4 is 8. 6 times 3 is 18 times 5th root of 7. Now I'm going to try to simplify the radicals. Remember, radicals are not simplified if you didn't take out a factor. So the square root of 18, I can break it down, tree branch. That's 2 times 9. 9 is 3 times 3. So there's a pair of 3's. So 3 goes out, that 2 stays inside. Don't forget that 8 in front, and then this is 5th root of 7. We can't do anything to that. So final answer here, 8 times 3 is 24, square root 2, 5th root 7. So 24 times square root 2 times 5th root of 7. Over here, same idea. 5 cube root of that thing times 3 cube root of that thing. Outsides go together. So 5 times 3 is in front. These are both cube roots, so they can combine to a single cube root and just multiply insides. And I'm going to rearrange. I'll put negative 12 here, 18 next to it. I'll put the a's next to it. A times a squared times b to the 4th times b squared. So I'll fix this. In front is 15 cube root. Now usually I don't multiply this, and you'll see why I'm saying, but I'll multiply negative 12 times 18 is negative 216. Then a times a squared is a to the 3rd power. B to the 4 times b squared is b to the 6th power. I'm going to do breaking down tree branch. Now the fact was, if you take a odd index root of a negative number, put negative 1, and I'll show you why. This I'm going to make look weird, but okay, let's make negative 1 times positive 216. That's true. Now negative 1, this look weird, but I'm going to draw 3 tree branches from it. Now negative 1 I say is really negative 1 times negative 1 times negative 1. Because negative times negative is positive times another is negative. So this is my triple right there. 216, I can say that is what we use. We use 12 and 18. So usually I don't multiply that. 12 is 3, 4. 4 is 2, 2. 18 is 2, 9. 9 is 3, 3. So I circle my triples. Here's triple 1. So negative 1 goes out. Here's triple 2. So 2 goes out. This looks over here's a triple 3. So 3 goes out. There's no numbers left inside. Don't forget that 15 in front. So let me do this. That's fine. So it's multiplied by negative 1. Alright, and then there's 3 A's. So A comes out. There's 6 B's. So there's 2 groups. So 2 B's come out, B squared. There's nothing left over. If I multiply all together, negative 15, negative 30, negative 90 is my number. And it's a b squared. Is there even odd here? The index is odd, so that doesn't matter. So that's my answer here. So instead of drawing that triple negative 1 thing I did, if you see a negative inside and it's odd index, just take out negative 1 and don't do that thing. Alright, more multiplying. If there are parentheses in most terms, you can still distribute, double distribute, FOIL, stuff like that. So you're now multiplying them singly. So here, 2 things times 2 things. This multiply both of these. So 4 outside times outside. 4 times 3 is 12. Then square root times square root. They're the same index. I multiply inside. 3 times 2 is 6. That's the first one. Next, 4 times negative 6 is negative 24. Just a squared 3. Then we'll work on these. So 5 times 3 is positive 15. Square root 2 times square root 2 is square root 4, because the 2's go together. 2 times 2 is 4. And then that's negative 30, square root 2. So right now there's no like terms. I'm going to try to fix things. I can't do anything to this square root 6, so I'll just leave it as 12 square root 6. Let me do this. Let me see what I can fix. I can't fix square root 3. Square root 4. You know 4 is just 2 times 2 as a pair. So 2 comes out. Also the 15 comes out. So really that's 30. So I'll draw it like this. That's 30. Square root 3, I can't do anything, so it comes down, stays like that. Negative 24 root 3. This 30 was positive. Then over here, I can't do anything square root 2, so that just comes down as well. None of these 4 things combine. I simplified every radical as far as I could. There's no more groups to take out. So this right here is my answer. Looks bad, but that's what it is. Alright, and the last type is division. When dividing, remember taking the root of a fraction, you can have a fraction inside the radicand. You have to split it into the root of the top thing divided by the root of the bottom thing. And if the denominator of a fraction has a radical or root, multiply by the top and bottom by the conjugate. If the denominator is one term, just multiply the same term. If the number is two terms, multiply the same terms but change the sign in the middle. That's the conjugate. Remember, conjugates create a difference of squares. Then once you do those two things, just simplify like normal. So first it says simplify this square root of 4 over 3. That's a fraction, can't square a fraction. So you're going to break the square root of the top divided by square root of the bottom. So we're not square rooting a fraction anymore. Take care of each thing separately. Well, the square root of 4 is just 2. That's easy. Over square root of 3. Right. I can have a square root in my denominator, so I multiply both the top and bottom by the denominator. Alright, so like that last slide, when you multiply this, top times top, because it's fraction is fraction, 2 times root 3 is just 2 root 3, because they're not the same thing. Outsides go together, insides go together. On the bottom, square root of 3 times square root of 3 is square root of 9. But you should know what the square root of 9 is. Square root of 9 is just 3. So 2 root 3 over 3. So here's a shortcut. If you have a square root times the square root of itself, it's just going to be the inside number. So example, square root of 5 times square root of 5 is just going to be 5. Alright, down here we have a square root of that fraction. So just like before, I'm going to break it up to the square root of the top by square root of the bottom. I can multiply the conjugate, or multiply the bottom. And you do a lot of things in any order you want. When I do this, the top will be square root of x to the 6th power, y to the 7th power, over square root of y to the 7th times square root of y to the 7th is just y to the 7th. Our square root times itself will be just the number inside. Now for the top, we can fix that. The square root of x to the 6, there's 6 x's, pairs, there's 3 full pairs, so x to the 3rd power comes out. There's 7 y's, there's 3 full pairs, but 1 left over, so it stays inside. And the bottom stays y to the 7th. Now here I remember even odd because I have letters. The x had an even exponent inside, 6. The index was even, 2, and it came out odd as a 3. So I need absolute value signs around this. Alright, and I'm almost done. If you have y on top and y on bottom, you do your regular exponent rules, division rules. When you divide letter by letter, you subtract the exponent. So lastly, the y3 divided by y7 will be y to the 4th on bottom. So my final answer is x cubed, that's right on top, square root y. On the bottom is y to the 4th power. So notice how this radical is on top. There's no radical on bottom. There's no radical of fractions. We simplified as much as we could. Alright, last one here. We have a fraction. There's a radical on bottom. Can't have a radical, like a root sign on the denominator. So you multiply the denominator. Top of the denominator, but you change the sign in the middle. So instead of -1, I'll put +1. That's the conjugate. Here, this is going to involve foiling. So if it helps you, you could put parentheses around this. That's just distributing the 2. If you do this, we're going to foil. I'm going to take care of the top first. 2 times root 5 is 2 root 5. 2 times 1 is 2. On the bottom, root 5 times root 5 is 5. Root 5 times 1 is positive 1 root 5. Negative 1 times root 5 is negative 1 root 5. Then negative 1 times positive 1 is negative 1. If I combine like terms, you should notice that root 5 minus right cancels out. When you do difference of squares, the middle always cancels out. So really, this is just 2 root 5 plus 2 over 5 minus 1 is 4. So notice when you multiply the conjugate, there should be no more radical on the bottom. Lastly, remember your answer has a radical on the numerator. You gotta check if you can reduce your fraction. Always reduce. Check the outside numbers. You can't change the root 5 anymore. But 2, 2, and 4, this number, and this number, if you can divide everything by the same number, you should. I can divide all of them by 2. So 2 over 2 is 1 root 5. 2 over 2 is 1 over 4 divided by 2 is 2. This is my final answer. If I type that in the calculator, in the original problem calculator, they'll be the exact same decimal. That's it. Thanks for watching. See you in class. Make sure you ask some questions. Bye.